Dipole-dipole interactions also help to explain what happens when water freezes. A bottle of water left in the freezer will shatter when it freezes. In turning to ice, the water has expanded. But why? In liquid form, the water molecules have enough kinetic energy to slip from one restraining dipole bond to another. But as the liquid cools, the molecules move more and more slowly until the dipole-dipole interactions begin to hold them in place. The attraction between the positive and negative poles actually lines the molecules up into a regular pattern or lattice. Once this happens, the water has begun to turn into a solid. The particles are still moving, but around a fixed position. For the positive and negative sides of the molecules to line up, the molecules are forced to spread out. So ice always takes up more space than the liquid water it formed from. The fact that water molecules have a more open structure in the solid than liquid state also explains why ice floats in water. It's around 10% less dense. When ice melts, heat energy from the surroundings is giving the molecules at the ice surface enough energy to break out of the lattice and begin to move in the freer liquid form. Notice that in these changes of state, the water molecules themselves are unaffected. What changes is the intermolecular bonding, the bonding between molecules. So when water boils and turns into a gas, it's still water. When water freezes, it's still water in a solid form. In fact, most substances can exist in these different states. The temperatures at which they change from one state to another will depend on the strength of the bonds within the substance and which bonds break or form to cause the change.